Hello everyone, welcome back to another video of Mr. Coder, and in today's video I'm going to show you how to solve Novice's mistake. Question E from Codeforces Round 957, Division 3. So one of the first programming problems that K100N look like this. Novice Monk has N friends, each of them gave him A apples for his birthday. Delighted with such a gift, Novice Monk returned B. B is less than or equal to the minimum of 10,000 and A times N. Apples to his friends. How many apples were left with Noobish Monk? And this guy wrote a solution, but accidentally considered the value of N as a string. So the value of N times A minus B was calculated differently. So in multiplying the string N by the integer A, you'll get the string S equals N plus N plus N as a concatenation of the strings A times. And when subtracting the integer b from the string s, the last b characters will be removed from it. And if b is greater than or equal to the length of the string s, it'll become empty. In learning about this, Core became interested in how many pairs AB exist for a given n, satisfying the constraints of the problem, on which this guy's solution gives the correct answer. And the solution gives the correct answer means it outputs a non-empty string, and the string, when converted to an integer, equals to the correct answer, which is the integer value of n times a minus b. So for example, 2, there's this 20 and 18. And if we do 2 times 20 is 40 minus 18, that's 22. And if we look at this, the string 2 20 times, and then if we take away the last 18, then we'll have 2 2s left, which is 22. And that's basically some of the samples. There's also 219 and 216. 219 times 2, and then minus 216, that'll be 222, which you can definitely get by. And if we think about it, there's not really like any obvious way of doing it. But so the only way that's pretty obvious is brute force. And how do you brute force it? Well, you're given the boundaries of the A and B. You're given that they have to be 10,000. B has to be less than or equal to 10,000. So that means that you would brute force like A and B, but then since there's T test cases of 100, so that means that 10,000 times 10,000 times 100, that's 10 to the 10th, which can't run in time. So there would have to be another way to like brute force this. And you'd have to think about an optimized brute force. And if we think about it, how many strings can you get of these like strings? How many possible strings can you get? Well, the only possible amount of strings would be like concatenating these like strings together and then removing a certain amount of them. So basically, what I did was I like had this current string, and then I set while its size is less than or equal to 12, and then I converted the string to an integer, and then I brute forced on the A, because you can brute force on one of them, you just can't brute force on both, because then you can already get the B by just multiplying the A by the original length of the string, and then subtracting the current length of the string. And it's really helpful to like just use it on paper, because paper, and then like to do equations to solve it, to find what this J or like actually B is. And if J is less than or equal to 0, then just continue. And then if X times I, and then you subtract J, if that's equal to Y, that means that they result in the same answer. Then I push back this IJ. And then after each time I push back the S index, and then I index, and then I do index plus 1, and then mod the length. You don't need to mod the length, but I just did, because that was what I was thinking of during the time. And then I print the size, and I print the A and B for each one. And that's basically how you get the correct answer. And it really does help. Like I did brute force some of them just to see like what are the answers to lead to like patterns and stuff, which is basically my approach to solving it. Because the not only the important thing is knowing the solution, but how to get it is also important. So I'm trying to show you how to like get it a little bit, and it's just optimized brute force basically. So if you notice that, because generally things can run in like 10 to the 9 operations. 10 to the 9 is a little bit of a stretch, but usually 10 to the 7, 10 to the 8 operations you can do, especially on Codeforces. But 10 to the 10, that's too slow. But if there's no like greedy way of doing it, then you try thinking of brute force, like some optimized brute force. And it of course involves a little bit of math, but it definitely doesn't have that much math. So yeah, that's basically how you solve Novice's mistake. Question E from Codeforces Round 957, Division 3. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.